Welcome everyone. Today our topic is types of sensor, and we are going to explore which are the different types of sensor which we can use in our prototyping. So going forward with what we are running under Zero to Maker is we are helping students to learn about making, which will help them to go further as an innovator and entrepreneur, and it has been designed under framework of Professor Nair. So today what we are going to cover is types of sensor. So you will be basically getting known to how many types of sensors are there in the market and how it has been used. Then we will see how it has been used for detecting the environment and surroundings. So what kind of environment we can detect. Then we will go forward with how it has been connected to different pinouts. So each sensor will be having different kind of pinout and different kind of structure. So we will be learning that kind of thing in today's session, and then we will also know about what is analog digital according to their pinouts. So we will cover up the basics one, and for this you don't need any hardware right now because it's an informative video today, and with the help of this informative video we'll explore much about in detail later when we will have the hardware. So let's go forward. So according to Wikipedia, we have made a list of sensors which is available in the market and it has been used into industry. I have made this list according to industry. It's not only limited to Arduino. So they have listed in this 10 different type of plus there are much more which I will cover. So total 16 and others, because there are some sensors which cannot be put as a category, but there are some special one which we can list. So we have here acoustic, sound and vibration, which basically works on wave and everything. Then second is the automotive, mostly used into automation or something kind of industry. Third is the chemical one, which react on some chemical and give the presence of some compound or some such kind of thing. Then we have sensors working on electronic logic, like principle, which is electric current, electric potential, magnetic and radio. Then they have some which detect about environment. So you can consider it will be different kind of environment on a temperature, weather, all those things, but related to climate change. So these are this. You can study more into this by clicking on the window, which I will show you at the end of the presentation. So let's go forward. So it is also having pressure, force, thermal, then different technological sensors and speed based sensors. Now it's the most important part, how we are going to learn about few more sensors. So as you say, I have couple of 30 of them, but I will explain in short time right now to cover up more better. So there will be some sensors which will be detecting distance, and this sensors will explain you all about how that distance will help you to do some logic. So you can use this as a in the car and all kind of structure. Then this is the motion sensor, where you have seen the gates opening and closing into the hotels or some malls. So then there will be color sensor which will detect the color, mostly used in the sorting industry where they want to sort the fruit or something like that. Then in the health industry we have pulse sensor. Whenever you visit a doctor, you will see they will put it some digital thing onto your finger and they'll measure the oxygen. So this is the pulse sensor. Then we have temperature sensor, humidity sensor. So those are like when the much humidity in the room, you want to turn on your AC, something like that. So we have couple of such kind of sensors. You can see there is one more row which detects flow, fingerprint, soil moisture, your touch. It can be metal, capacitive, then sound, whatever you are speaking, according to a decibel it will work. Then you have pH, which will detect the pH of the sensor. Now there is much more other, like pressure, according to force pressure or atmospheric pressure. RFID, where it will detect particular tag with the electronic chip. Then we have light, which is LDR. So it will detect how much light is outside, and according to it, it will switch on or switch off your street lights. So that is one more kind of sensor which we will be using. Then there is gyro, which detects your XYZ position with the orientation of U. Then we have accelerometer. According to your speed and motion, it will give you the how much acceleration it have. Then we have some atmospheric sensor called rain sensor. These are the sensor which Arduino have as in family. This is tilt sensor. So tilt, basically when you are having a vehicle and something accident happen, then how you identify the vehicle is been fallen. So we can use tilt sensor. Then there is gas sensors, different kind of gas can be detected. We have a joystick sensor where you can control the inputs according to your movement of joystick. So it will take your X and Y direction. We have flame sensor to detect whether fire is there or not. We have IR detection where you will give a bombarding of IR gun to send some data, and according to that data it will react. So basically your TV remote is a kind of IR gun, but the sensor present in your TV which detects which button you have pressed, it is IR detection. Then we have voltage sensor which detects about how the voltage is going up and down. Then for pollution and dust monitoring, there are some sensors which work on laser based technology. It's dust sensor. Then for health we have ECG sensor which gives you the pulse rate and heartbeat rates of through your checking of your body. Then we have flex sensor. It detects your the bending of particular strip. It's called flex sensor. Then we have weight sensor which will detect with the help of load cell. So according to your weight, the fluctuation of the voltage will give you the output. We have IR sensor. So IR receiver. So that is also a kind of sensor. So IR detection is just the reflection one. IR receiver is the TV one. So I did a mistake here. Then we have camera sensor. So there are camera available which you can add onto Arduino and click some pictures and store into SD card. Then there is simple potentiometer in the old TV or radio. If you have seen, you can like move the knob, and according to the knob the volume will go up or down. That's the potentiometer. We have muscle sensor which detect your movement from muscles, and that muscles will give some electronic difference, and through that we can detect and make our motor work. We have vibration sensor, then metal detection. Many of you have seen the same device with the people. It is a ring kind of structure which detect the metal. We have location, basically GPS and our location based devices. Then we have piezoelectric where it detect the pressure. So these are the 30 sensors which like many people are using in Arduino projects, and mainly when you are going to learn about Arduino or electronics or going to make project, majorly the input sensor will be around it. And we have much more other sensors which we can use, but it is according to your requirement of industrial project. So now let's go forward and explore about sensors. So as you see, I will start with the temperature sensor, and in temperature sensor this is the most common one which you will be getting easily by nearby store. It's a LM35, and using this kind of sensor you can measure the temperature. Each sensor will have some technical specification, and in this technical specification you will get to know more about their range of the working. So here you can say this temperature sensor work with -55 degree to +150 degree Celsius for detecting the temperature, and there will be a difference of the accuracy also. So you will be selecting the temperature according to it. This is showing you the pinout also. We will come to the pinout part little later. So let's go forward. This is the humidity sensor. So in Arduino, whenever you are using, there will be a slight difference. So the sensor part is the upper one, which is the blue one. Now this is the sensor part which you can see. Now getting back to this part, this is the module. So this is the sensor when been added to a circuit and some more component is added, then it becomes much easier for use for the Arduino purpose. So that is how it becomes a module. So this is the DHT11. We have couple of high range sensor in this which is called DHT22. But just think like this as a humidity sensor. Whenever you want to record humidity, it helps you. Now this is the IR sensor, which is basically used in obstacle avoiding robots. So which basically bombard the IR, but whenever it is receiving back, so it identify whether something is in front of or not. So you can see this. These are the IR LEDs Okay, but this is the entire circuit, helping it to create in a very simple form. So you just get 3 pin which you can connect with your Arduino. So this is the LDR sensor. It detects the intensity of light. So according to the light, it says like whether the light is there or not. It also says how much light it is. So that depends on the analog and digital, which I will be talking little later. So it detects the light. This is a sound detection sensor. It detects the decibel. So according to your volume, so it vibrates some membrane onto the microphone, and according to that vibration, it gives you the output, and that you can add into your Arduino. So this is basically your sound detection sensor. Now you can see this is the PIR sensor. So you have been visited many hotels or some malls or something where some doors work automatically, and this particular sensor detect the movement of any object or substance. So it has a very systematic design of a dome. So it reflects back the IR rays and says that some movement or voltage difference is there. So we can detect that and give a signal to motor to open the door, or it is used also in security. So if some movement is there at the night time, it will just raise the alarm. So this is how the types of sensors are so many, but we will be covering in a short. Now let's go and understand how it has been used. So we'll learn a simple one project. I talked about, like, I will be explaining 2 projects over here. So here let me explain the project which we can make using PIR sensor. So you can see here, whenever you will be working with the sensors, as I said, the logic will be stored into Arduino Uno in the last session. So Arduino Uno will be having a code which will be connected with the peripheral components. So the input comes through a PIR sensor. So this PIR sensor will be sending an input to Arduino in a pin number 2. So whenever something it detects, it sends a signal. But to run the PIR, it also required 5 voltage of ground and plus. So we can see from here, we are providing the plus and minus power to the PIR using breadboard. Now we will have a logic inside it. Whenever PIR detects a motion, it will give some voltage difference to Arduino. And once the Arduino detects some voltage difference on pin number 2, there will be a one more command which will be sending to a pin number 3 to raise the buzzer. So as soon as it detects the motion, it will raise the buzzer, and it will also turn on the LED as a high. So this is how a simple project on Arduino is working. It is very simple. Some couple of 10 lines of code will help you to design this kind of project. Now going further, we have a ultrasonic sensor. So this particular sensor work with the waves, and these waves basically travel and reflect back. Every sensor have their limitation, but we will be talking that in a very detailed form in next sessions. But this basically works on your sound waves emitted by the emitter and transducer. Okay, so you can see there is one transmitter and there is one receiver. Okay, so the outer peripheral is considered as a, like you can see there is an kind of disc-like structure. So that will be basically giving you the outcome. So now let's go further and understand the same similar project, how it will be working. So as I said, this is the second number of project which you will be understanding like how this basically work. So here we have used that particular ultrasonic sensor. We have pinned up in a diagram which you can say we have added onto a breadboard, and on that breadboard the wiring you can see it has been connected to Arduino. So there are 2 pins going to Arduino, and there are other 2 pins which is supplying the power supply to ultrasonic sensor. So this is how the sensor is getting powered, and it is sending the data to ultrasonic. Now we have one more output component which is called display. This is basically I2C display. It also gets some command from Arduino, which is basically the distance recorded by ultrasonic. So there will be a logic stored in Arduino which takes the input from ultrasonic, calculate it, and display the outcome into LCD. So this is the second mini project which you can practice once you have a proper component with you. So basically this gives you an simple idea about how the sensors will be connected to a simple circuit to as a working system. So this explains you how ultrasonic detects the distance and display into LCD. Let's go forward and understand the couple of more sensors. So before going to couple of more sensor, let's understand the pinout, because there are many sensors I have added. So I don't want you to just say about sensor, but technically we also need to understand about pinout, because this will be the key point which you need to learn, because every sensor will be having different pinout. So here I have listed 3 slides which talks about different common pinouts which you will be observing in any kind of sensor. So there is 2 common thing which you will see in any kind of sensor is, one is VCC and second is GND. Now VCC and GND is basically the power supply to sensor, because every sensor to function its main physics. So basically every sensor work on physics. Now to work with that physics they require power, because all of them are working basically on electronics. So the 2 pin common thing which you will see in every sensor will be VCC and ground. VCC means you have to supply 5 volt. Some of the sensor will have some variation to like 3.3 volt to 12 volt, but it depends. You can see their data sheet and identify what actual power supply they need. Then there will be other pins which will be talking about what kind of data they will be sending to Arduino. So in ultrasonic you can see there is 2 pins. One is trig and other is echo. So this trig and echo is the data pin which need to be connected with Arduino, and that will be sending the signal about the data. So like how much the distance it is. Now we have the other sensor. Here VCC and ground, as I said, it is common. This is a gas sensor. This gives us the 2 different output. So one output is AO and other output is DO. So AO stand for analog output and DO stand for digital output. So what is analog and what is digital, I will share very simply. So if you can say that whether the speed is how much, so you can say it is 43, then you can, that is analog. So you can actually measure how the difference is. But now if someone asks, hey, whether the speed is 50 or not, so whether it is 50 or not, so you can say 0 or 1. So digital output will be saying the threshold, so trigger only, so whether the gas is there or not. But analog will say the percentage of gas detection. So analog and digital is also simply like your clock. So clock have the you are using the bikes right now. So before that there were some like analog where it has some kind of arrow which moves like this and say what is the speed. Now you have digital sensor which directly display the speed. So that kind of thing it is. Let's go further. So this is the second pinout slide. You can see one, we have a ADXL335 which is a gyro kind of sensor, which basically whenever you have used, like your mind, when you are standing, your brain helps you to stand straight. Why? Because we have an inbuilt liquid based system in our ear which says about the gravity and our perpendicular to the body, so perpendicular to the ground. So same way the gyro sensor is according to your tilting, like when you tilt forward, so it says it is forward. So for that they use XYZ and it gives you some idea about how much you are forward, how much you are backward, like that. So here there are 3 pin as an output which will go to Arduino. There is one pin 6 which is state pin which will also go to Arduino. Now the second sensor is the pressure sensor, atmospheric pressure sensor. So here you can say there is SDA and SCL. So that is one more kind of I2C communication which is much simple, not at all hard, but that also goes to Arduino. And this is how you will understand, like every sensor will have different pin, but you will easily able to identify using Google how to connect where, but there will be different pins. So I just wanted to clear that idea. Let's go further. So we have one more sensor which is joystick. So joystick will be majorly used for using into servos, okay, like controlling the servo or some movement. So here the joystick have, like, one is the SW which is for switch present on the top of the joystick. Then we have VRY and VRX. So RY and RX is basically the direction of that particular joystick. So that will that basically is formed with the help of potentiometer. So that gives you a directional based outcome, and that 3-point pin will go to Arduino. Same way we have a RFID. So RFID has couple of more pins. You can see SCK, MOSI, MISO, all of this how to connect with the Arduino. It's easily available on Google, but there will be couple of such pins. So this will give you an idea about whenever you will be working with the project, you have to get to just know about search on pinouts, and you will get to know about the pins, and from there you have to make the connection, and all the connection are available on Google how to make it, so it's much easy. So this was all about pinout. Now we will be checking all different kind of sensors which we talked about. So this is the range sensor. It works on the like physics called resistance. So these are some conductive lines. On that, once the water is there, then it find that okay, the resistance is low now, so it detects the rain according to it. This is the additional module which converts the signal and send it to DO or AO according to the requirement of the project. This is the color sensor. It detects the color. So it detects the color as red, green, blue, and gives you in a hex code, which you can easily understand using some coding parameters and identify the color. This is the capacitive touch. So this is basically when you touch, it takes as a signal. So this particular sensor pad which you are seeing as a circle, this is the capacitive touch area where you touch and it gives you the signal. This is the flow rate sensor where you can identify what's the flow of the water is, so or the air is. So through that you can calculate how much liter of water has been passed through that particular pipe. This is the soil moisture sensor by which you can make some agriculture based product where you can identify how much moisture the soil have. It basically detects the current passing through this particular electrodes from one electrode to other electrode. So that is basically the soil moisture sensor. This is the fingerprint sensor. So it detects basically your fingerprint and convert into digital signal, and it send it to your Arduino. This is the gas sensor which we already checked. So it detects different type of gas like carbon dioxide, monoxide, then different alcohol. So different kind of gas it detects, and according to that they have the various MQ series. So MQ3, MQ2, MQ7, MQ135, so which you can Google and understand. But we have a series of gas sensors using into this. So this particular center part which you are seeing, this is the sensor, and this is the entire module attached to it. This is the tilt sensor which we are talking about. So it has a small mercury in it which connects with the two thing and says about its orientation. This is the pulse rate sensor which basically detects the pulse rate used from the fingertip. It is a non-invasive design and much simple to use. This is the accelerometer sensor. You can see the different pinouts on it, and it has those pins to connect with, and it gives you the XYZ direction. That is atmospheric pressure sensor which detects the pressure of the atmosphere. So it will give you how much bar of pressure it have. This is the force pressure sensor. So force pressure is when you put a finger and put a pressure, so it detects that pressure. This is the pH sensor. So in the water, if you want to, or in some chemical you want to identify how much the concentration of the pH is, you can use this sensor. This is the RFID. So you can use this RFID's tag to identify which tag it is, and according to it you can unlock or lock the things, or you can even identify their identity, so whether to give them a pass or not. This is the dust sensor. So this is the optical dust sensor which works on the principle of laser. So whenever there are some dust particles going in, it will tell you about how much dust particle it presents into this. It has a fan which actually takes the air in constantly. This is the ECG module. So it basically gives you the systolic and diastolic of your heartbeats and gives you the data to your Arduino. This is the joystick which will gives you the XY directional movement, and that signal can be used for controlling servo or other motors. This is the flex sensor. So as I told, when you bend this flex sensor, so it will generate a voltage difference between the current, and through that you can identify how much the bend is. It is used for making some design which can give you the output using hand movements. So some robotic surgery and all those kind of projects has been made through this sensor. Now this is the weight sensor with the load cell. So load cell gives you the voltage difference in a very less ampere. So this sensor amplify it and gives you the outcome saying how much the weight is. It has been used in many of the industries for detecting weight, and according to that the partial separation and everything has been done. This is the IR remote. Basically this is the receiver, the blue part, and this is the remote which bombards the signal, and through that you can detect what kind of signal it is, and according to that you can command with the code. This is the camera module which can click picture or record something and store into a SD card module. This is the muscle sensor. So you use some patch on your body, and same like ECG, and when your hand is moved it gives you the detection of it, and according to that we can control motors. So for prosthetics and all, this kind of sensor has been used. So these are some couple of sensors, and we will be covering how this sensor work with the physics into next sessions. So if you have any comment or something, you can write in the comment or text us on our number which I will be displaying soon. This is the simplest potentiometer which you have used so many times, like in your home with some apparatus where you adjust the volume or something. So this potentiometer also takes an analog value and differentiate it according to the voltage, because it basically it's a variable voltage converter. So basically you can change the voltage output to a device. So thank you so much for attending the session, and we'll like to have your more response and your in your comments, so you can tell about what you want to learn, and according to it we will start making the sessions and make it available on YouTube. And we will also like to make some PPTs on communication like GSM and all, which we will be presenting little later. So this was the initial one, so slowly we'll be helping you much better. Thank you, and this is our WhatsApp number on which you can communicate, and if you need any help you can text on that. Thank you.